So now we're looking at ratios and how they relate to scale drawings. Now, I've got to say, this is unbelievably important. If you are doing any kind of fabrication, okay, building sites, sheet metal fabrication, boilies, anything like that, if you cannot read a scale drawing, then you're going to be useless to them, okay? Cannot emphasize this enough. One of the big complaints that employers have is, yeah, okay, people are late and people might be on their phone, but they can't read a plan. They can't just be given a scale drawing of the job and just be trusted to do the right thing with it. So this is immensely relevant, okay? So it's a ratio. So let's say I've got this, okay? Now that's the scale that most house plans are drawn in. Not all, but a lot of them. Okay, now what does that mean? Okay, so it's 1:100. Over on this side, you have the diagram. Okay, measurements off the diagram. And over here, that is real life. Okay, so one whatevers on the diagram represents 100 of the same units in real life. So if you are given a scale like that, and then if you ask, is this centimeters or is this millimeters, then you actually don't understand what's going on. Because the answer is yes, it's both. It can be whatever you are measuring in. You could go inches. 1 inch on the diagram is 100 inches in real life. 1 millimeter on the diagram is 100 millimeters in real life. One width of this pen on the diagram is 100 of these widths of this pen in real life. Okay, it doesn't matter what the units are, so long as you're using the same ones. Okay, so that's what's going on there. You won't, in real life, you won't need to create scale drawings. That's a very specialized drafting skill. But oh my goodness, the vast majority of trades, you are gonna be engaged in interpreting them, okay? It's just everywhere. All right, so let's have a look at how do you do it. So this is on page 11. Let's just zoom in here a little bit. All right, so we want to find the real life distances A and B. So what information have we got? Well, this says it's 1:250. So that 1 is the diagram, measurements on the diagram, and that there is real life. Okay, so in other words, every one thing I measure on this diagram is scaled up, if I times it by 250 to represent what it is in real life. All right, so let's actually get some measurements. So what do we got there? I'm going to call that 6.5 centimeters or 65 millimeters. Let's go millimeters, because if you were working on a job site, it'd be millimeters. All right, so I've got 65 millimeters. So I've got to scale this up, okay? I've got to blow this up to be real life. Clearly, if this is a piece of land, it's not, you know, it's not this big, okay? It's been shrunk down to fit. And how it's been shrunk down is every measurement has been divided by 250. 250, okay? To shrink it down onto this page, every single measurement's been divided by 250. So to get it back up to real life, we've got to times it by 250. All right, here we go, times it by 250. So 65 times 250 is 16,250. Well, what units is it? It's millimeters. Okay, so to get that to meters, that'd be 16.25 meters in real life. Okay, so that there, from there to there, in real life, it's 16.25 meters. All right, well, let's look at B. Measuring it straight off, I would call that 5.5 centimeters, or I'm going to go 55 millimeters. All right, well, same job. I've got to times it by 250. 55 millimeters times 250 is 13,750 millimeters. Okay, so that's what I've measured, actually physically measured off the diagram, and it's in millimeters. So when I scale it up, when I blow it back up to real life by timesing by 250, it's still millimeters. Okay, the units are the same. If you wanted to talk meters though, okay, righto, well let's convert that. That's 13.75 meters. By the way, just as an aside, you need to know how to go from millimeters to meters and back again if you're going to be anywhere with any kind of construction, fabrication, anything that you've got a tape measure in your hand. You are going to have to be able to do that. Okay. All right, let's look at this next one. So now this scale is 1:1200. Okay, so in other words, to get this diagram, all these dimensions have been shrunk down by a factor of 1200. In other words, they've divided each measurement, each side, each dimension. It's been divided by 1200 so that it becomes this diagram here. All right, well, we've just got to blow it back up by timesing it by 1200. Well, what have we got? Here's I reckon you could call that one 56 mils. Okay, so 56 millimeters in this one. Now, but I've got to times it by 1200 because that's my scale factor. Timesing it by 1200, 56 by 1200, I've got 67,200 millimeters. Okay, remember I started in millimeters, so I finish in millimeters. But let's get it to meters because that's a fairly big space there, 67.2 meters. All right, now over here, I'm going to call that 54. Oh, yeah, I'll go 54 millimeters. So 54 millimeters, timesing it by 1200. 54 times 1200, that's 64,800, but get it to meters, it's 64.8 meters. That one there is millimeters. Okay, so 2 steps, you measure first. Now it doesn't matter whether you go millimeters or centimeters, because whatever units you start with, that's the unit you finish with after you've done the scaling, after you've applied the ratio by timesing it. Okay, then you could get it to meters at the end. Okay, but whatever the scale is, I could have a scale of 1:2 million. Okay, in fact, some maps are drawn to that kind of a scale. The actual dimensions on the diagram have been shrunk to fit on the page, and how you shrink them is by dividing them by whatever the scale factor is, whatever that ratio is. Okay, so that's how you deal with a scale diagram. As I said, unbelievably important. You will not survive in fabrication or construction unless you can do this. Okay, boilies, sheet metal, joiners, chippies, in fact even plumbers, because they have to read house diagrams as well. If you're interacting with a house plan in any way, shape or fashion, you've got to be able to do this. All right, off you go.